All right, so Tom and George play golf. Tom's score X has the N 110, 10 distribution. What does that mean? Normal distribution, mean 110, standard deviation 10. Good. George's score varies according to a normal distribution as well. If they play independently, okay, that's great. Check. That means that we can be able to calculate variances and standard deviations of their combination. We want to know what's the probability that Tom will score lower than George and thus do better. If you know anything about golf, a low score is a good thing. Yeah. You want to try to get the ball into the hole in the least number of hits, called strokes, as possible. Okay, so X is Tom's score. Okay, so seriously, like, this is what I do when I solve these problems. Like, I just kind of get myself organized first. So here's Tom's score. We know that mu sub X is 110. Standard deviation of X is 10. Y is George score. Mu sub Y is 100. Sigma sub Y is 8. And they are independent. Great. So that's just kind of like my own little pull everything out that I need to. Okay, so what is the probability that Tom X will score lower than George, less than Y, and then do better? Okay, so this is essentially all we're doing. The probability of X less than Y. And we've never seen this before, where we have variables on both sides of the inequality. We've always had some number, right? We've always had some normal distribution. We've had some number here, like a z-score, whatever it is. There's some number that's there. We've never seen this before, where it's not equal to a number. So let's do some really fancy math called subtraction. And move it over. So essentially what you're doing is you're making a new random variable called x minus y. If you don't want to leave it as x minus y, then give it a new variable name, like a. And say, let a equal x minus y. Or not. It's completely up to you. So let's think about what would happen next. If I have two separate distributions that are normal distributions, when I subtract them, will they also be normal? Is it still normal? Is it double normal? I don't know what that means, but if I, so that was not, this was transformations. If I take a normal distribution and I subtract out a normal distribution, is what remains still normal? Yes. Yes. This is a normal distribution. This is also a normal distribution. If I subtract them, then what remains is still normal. Too normal. Okay, so what we want to do is we want to then take this thing, which is the scores, and we want to convert them into standard normal. Okay, well, so usually we have like A is less than 5. And so then that number 5 goes here. So I'm going to write it in notation first. So I'm looking at this value, which is really x minus y, minus the mean of x minus y, over the standard deviation of x minus y. So again, this is nothing new. X minus the mean over standard deviation. The only thing different is all these little subscripts today. So this is going to become P of z less than, well, x minus y we're saying is 0. We're using 0 as that benchmark. What I don't know is what the mean of x minus y is and what the standard deviation of x minus y is. So I need to take a little detour. I need to know the mean of x minus y. So I'm allowed to subtract their separate means. I can rewrite this as mean of x minus mean of y. What was the mean of x? 110. What was the mean of y? What's this difference? 10. That goes right here. Okay. How about standard deviation of x minus y? Can I take the standard deviation of x minus the standard deviation of y? No. Good. No. So what do I do? And what do I do with the variances? Yeah, you add them. So how do I compute the variance of x? And the variance of y? So this is 164. So what's the standard deviation of x minus y? And that goes right here. Hello. So, using your favorite method, you can just compute this real quick. Z is less than negative 0.78. Go to your table and find this value, 0.2177. Or, if you prefer, you could do a normal CDF. Something like negative 10 or maybe negative 100, negative 0.780, 1. If I plug in my standardized values, or I could do a normal CDF with, say, negative 1,000 or negative 100, 0, 10, 12.81, using the mean and the standard deviation that we computed. So you've got several different ways to go about it, as long as you're labeling low value, upper value. Here's the mean of x minus y. Here's the standard deviation of x minus y. Do you get the exact same answer? No, get like 0.2175. If I do my calculator, 2177 on my table. So we would say something like about 22% of the time in context, what would we say here? Yeah, Tom does better than George. Okay, so tonight's homework is on this stuff, transforming and combining.